Hello, everyone.
Hello.
Welcome to today's class. I can see most of you are in and hope you can hear me clearly. Can you hear me?
Yes, madam.
Yes.
And are you able to see
Louder.
whatever I'm sharing?
Yes.
Thank you. So I think we can start today's class. It's a new topic we are going to start. And kindly, someone can take us through the title of our today's lesson. Daisy Cherono, if you can get us,
Yes.
read for us the topic.
Okay, the topic is solving first order differential equations using the methods of undetermined coefficient.
Thank you so much. As you've heard, this will be our today's topic. So by the end of today's lesson, these are the objectives. I hope you'll be able to sorry for that. So by the end of today's topic, you should be able to define the first order differential equation and undetermined coefficient method. And secondly, you should be able to identify the steps involved in undetermined coefficient method. And thirdly, you should be able to solve the first order differential equation using the method of undetermined coefficient. So we are going to start by our first objective, that is the definition. Briefly, who can tell us what do you understand by the word first order differential equation? Ian. What do you understand by the term first order differential equation? If Ian is not in, kindly, Clivius, you can tell us what you understand by the word first order differential equation. What do you understand by the term first order differential equation?
Differential equations are differential equations that do not have powers. They are not raised to any power.
That is a good trial. And you can tell us what is undetermined coefficient method?
I can try.
Yes, Teresia.
Undetermined coefficient method. This is whereby we find the value of y, where in our general solution, that when we are calculating the complementary function, the values of some values are unknown.
Good trial, Terry. So as you've heard, everyone who has answered has tried there on this, the solution, those are the definitions. So we can see here the definition of the first order differential equation as if we are given dy dx is equals to f of xy of two variables, that is x and y, with its function fxy defined on the region in a xy plane. It has only the first derivative dy dx, so that the equation is the first order and no higher order derivative exists. So that means the first order differential equation is the equation that has dy dx as the highest power. The highest power is 1. And when we come to undetermined coefficient, this is a method given by y is equals to YCF plus YPI, where YCF is a solution of complementary function and YPI is the solution of particular solutions. So we can see the steps that is involved in this formula, this method. That is the first method. We find the complementary solution. That was our YCF. And firstly, we let our f of x be equals to 0. Once you let f of x to be equals to 0, you find the characteristic equation. And then after you've had your characteristic equation, you solve your characteristic equation to get your YCF. And then the second step is find the particular solution. That is when you let your f of x not equals to 0, and then you'll find your YPI. We are going to have an example so that you can see how the method works. So we have our first example, that is solve the following first order differential equations using the undetermined coefficient method. And our example is 2x prime minus 2x is equals to negative cos t. Yeah, and tell us what x prime represents in differentiation.
It represents dy over dx.
That's a good trial, David. And it's true, our x prime represent dy dx. But in our case now, our x will be representing dx dt. That means it's the first derivative. And that means our equation is a first order differential equation. So to solve the equation, we start with the first step. That is getting XCF, the complementary function. And the first thing we do is we equate our f of x to be equals to 0. As you can see here, because we've said 2x prime minus 2x is equals to 0. And so when it comes to finding the characteristic equation, you let dx dt to be r. So wherever we have x prime, we substitute with 2r so that we have the second equation, that is 2r minus 2 is equals to 0. And then when we equate, we take negative 2 on the other side of the equation, we have 2r is equals to 2. That means our r will be
1.
Thank you. Our r will be 1. So our complementary function will be given by x is equals to cf is equals to c1 exponent t. We could have had another function up here in kando ya t, but now our r is 1. That's why we have exponential t. But if we had like our r could have been 2, then we could have our complementary function as c1 times exponent to t. So we move ahead to the second step, that is finding the particular solution. So since we can see from our equation, we had the non-homogeneous part of the equation as negative cos t. Once the non-homogeneous part is a trigonometric function, our xpi will be given by a cos omega t plus b sin omega t. But for our case, our non-homogeneous function, our omega is 1. That's why our equation now, our x CF will be a cos t plus b sin t. So we want to have a function that is f that will represent x prime and x by itself. So the first complementary function will represent our x. So we want to differentiate this x of complementary function so that we can have x prime. And what happens when you differentiate cos t? A cos t, what do you get? Teresia?
Negative A sin t.
That is good. So when you differentiate A cos t, you get negative A sin t. And what happens when you, what do you get when you differentiate B sin t? Ian, are you around?
We have B cos t.
Yeah, that is good. So when we differentiate, we have our x prime as negative A sin t plus B cos t. So we substitute these solutions of ours back to our original equation. That was 2x prime minus 2x is equals to negative cos t. So wherever we have x prime, we substitute with whatever that we have differentiated up here. And wherever we have x, we substitute with our f, x, cf, sorry for that. So we have this equation here. So we multiply and we collect the like terms together so that we have this equation. Once you've multiplied, you will collect the values for sine together and the values for cos t together. So in my equation, I've simplified it and I had 2b minus 2a is equals to negative 1. Those were the coefficients of cos t. And then negative 2a minus 2b is equals to 0 were the coefficients of sine. So after solving the simultaneous equations, we get that a is equals to a quarter, and then b is negative a quarter. So once we have our values for a and b, we substitute back to our xcf, that is our complementary function given here in step 2, because you remember our complementary function was given by a cos t plus b sin t. So we substitute wherever we have a with our value of a, and wherever we have b, we substitute with our value of b. Once we substitute, we have our xcf as a quarter cos x minus a half sin x. So in general, our x is equals to, now we bring the two equations together. That was the complementary function and the particular solutions. So we have c1 exponent t plus a quarter cos x minus a quarter sin x. And this will be our solution using the undetermined coefficient method. So that is the end of today's class. And before you go and try your assignment, kindly, who can remind us, or we can help each other review today's class, and you can tell me what you've learned so far.
Today we have learned on how we can solve first order differential equation using the undetermined coefficient method.
That is correct, Terry. Thank you so much. And what have you learned so far about the undetermined coefficient? Daisy?
I can try
Yes, Clivius.
to solve the first order differential equation using the undetermined coefficient.
Yes.
We use the formula y is equals to ycf plus ypi.
Yes, very true. Yeah, that is very true. And you've seen the steps that is involved in solving the first order differential equation using the undetermined coefficient method. I hope you've learned something. Kindly, I want you to try this example. Sin x dy dx is equals to cos x. And I hope you will submit it during our next lesson. Have a blessed evening. And bye, everyone. Let's meet in the...
Thank you, Mwalimu.
You're welcome.
Bye.
Bye.
Bye.